What's going on, guys? Michael here from 3D Print Everything, and I've got a little bit of a different video for you today. So today I'm out at the North Texas Auto Show. So we are here where the majority of manufacturers have brought all the brand new vehicles for you to test out and look at. And because this is not a car channel, I'm not going to go through and look at all these vehicles and review them, but I'm just going to show you the booth that I am at. So this is more of an update on a separate field and project that I'm working on over just the 3D printing. But I want to show you just a couple of things. So this car here, this is by X Performance. So they build really, really nice top quality machines, complete frame off restoration work. You have essentially a flawless build here. So Victor is the owner of that company there, and he does that type of work. He also has this amazing car, which is a car you probably will not see again. So this is a 1932 Bugatti type. I forget the exact type that it is, but this is essentially the very first roadworthy car that Bugatti made. So before this, Bugatti was making race cars, and then they ended up saying, okay, we're going to make a roadworthy car. So they came up with this car here. So I'm just going to give kind of a quick little run through of it. This car is evaluated at like $2 or $3 million. Just an amazing build.
The cast aluminum fan up front, you know.
But what is super special here is this Kinetic drive. So this is what I want to highlight here. This is some new technology that the owner here, Ray Sherry, in the suit back there, came into my shop and wanted me to scan some brake parts for him so he could put them in a 3D model that he's using here. So we use some of our 3D scanners to help scan some of his parts. You can see the little video of this thing doing a burnout. But essentially what's going on here is you have a big flywheel, and this flywheel is the propulsion of the car. So you've got an electric motor here and a gas motor, and you can use either one to then rotate, excite, and spin this flywheel. As that flywheel is then spinning through this open differential that he has, you can apply the brake here, and because this is spinning and now that's braked, it'll send the power to the rear wheels. In the production model, it won't be a big differential like this. It'll actually be a much shorter, about 6-7 inch transaxle design, which is actually on some papers over there of what the transaxle is going to look like. And you could tuck this up much tighter on any other vehicle. So on a setup like this, with this size, you can end up making over 1,000 to 2,000 horsepower a second and put that to the wheels. On a race car application like what is on the screen there, you would have a flywheel made out of a higher tensile strength steel, a higher PSI steel, 350,000. It would be about a 350 pound flywheel, and that would give you about an 8,000 horsepower application. So for racing, this is going to be awesome, but for stop and go, it's also awesome because the way that he has the transaxle set up, that as you're braking, if you're using this in an everyday sense, the power, 95% efficiently, will be put back into the flywheel. So every time you brake and you apply the brake, it'll put the power back into the flywheel. So you can put this on a vehicle you have now, like some type of, 2004 pickup, really any pickup from whenever to brand new. Put this in line, it would replace your drive shaft, and you would get all of your power coming from the flywheel, and would otherwise only run your motor at its most efficient RPM just to spool up the flywheel. This can also be done to build purpose-built race cars, purpose-built dragsters, purpose-built circuit cars. So we're looking at building a drag car, a road course car, and potentially even a top fuel competing car. But this is Kinetic Drive.